Hi, everybody. I hope y'all are having a good day so far. Like I posted in my announcement, I don't know if anyone saw that, but I'm going to be working through a couple of practice problems. I'm going to be working on basically balancing a chemical reaction. The videos for that are available on their Canvas page, but I've also just kind of got instruction or that I'm going to walk through because I feel like it's the kind of thing that it's a little bit intuitive. Simply if you look at it from, you have to balance them. Just a second. Thank you. So you just have to get the things that are on the left side to be equal to things that are on the right side. So the question that I'm going to be working through, there's actually two of them that I'm going to be working on. They're very similar to questions number, I guess that's number 12 and 13. No, it's number 13 and 14 in your homework, in your sapling homework. So the first one, number 13, gives you four different equations, reactions, and asks you which one of them is balanced. And that word balanced, I mean, that's kind of the central part of it all. So the first thing is, let's see. So the first equation that you are given, just a second, there we go. Okay. The first equation that you're given is BaCl2 plus Na2SO4 yields BaSO4 plus NaCl. Now, does anyone see where the, I guess, sort of disruption is, where it's not balanced? Well, this one's kind of simple and straightforward to pick up on. And rather than just say, oh, well, where it's not balanced, let's try to go ahead and balance it. This one's what's known as a metathesis reaction or a double displacement reaction. And this is ionic substances mixing together to produce a product. Now, this one, we've got two chlorines, only one chlorine on the product side. We've got two sodiums and only one sodium on the product side. Bariums, those are equal. Sulfur, oxygens, those are equal. So really all that we need to do in order to balance this is we can throw a 2 out in front of it. That's all that you would need to balance it. But since that 2 is not there, well, this equation isn't balanced. Okay, so the next question, the next option is 1/2 PB, and then we have parentheses NO3 2 plus Ki yields PbI2 plus KNO3. Okay. Now, this one's a little bit tricky and a little bit complicated because you have that 1/2 PbNO3. I would argue that anytime you see that 1/2, you should kind of be clued in on that something's off, because one of the hallmarks of a balanced chemical reaction or chemical equation is, well, you have whole numbers. And so rather than look at this and say, oh yeah, it's good to go because, well, we have this NO3 2 and we can divide that by 2. Well, what does that mean? That means you have half PB as well. So you have 0.5 PB. Well, what do you have on the product side? You have 1 PB, one lead, atom or mole of lead, or however you want to look at it. That's going to be a source of imbalance. Okay, so that's kind of your, I would argue that as soon as you see that 1/2, you should think something's wrong, then dig a little bit deeper, and then you say, okay, my concerns were confirmed that it is not half PB, or sorry, it is not balanced because we have half PB and we have 1 PB on the product side. Does that make sense for everyone? Or does anyone have any questions about that? Okay. So then the third equation is 2Al2. And we've got SO4, 3. This is an ionic compound known as the aluminum sulfate, or if you were in the United Kingdom, I think they say aluminium. I've seen movies, I've never been there. 4, and then we've got in parentheses NH4, 3, and that's PO4. That's ammonium phosphate. Those are polyatomic ions that pair together to make a ionic compound. And I can't, let me just see the chat. Okay, good, nobody said anything. Then I've got 4AlPO4 plus, and that is 4NH4, 2SO4. Okay, so, well, one of the things that kind of clues me in as a potential source of imbalance is in this, we've got 2 copies of this compound. And in each one of them, we have 2 aluminums. So we've got 4Al. Okay. How many over here? Well, we got 4Al there. So the aluminum is balanced. I'm going to check that off. Sulfate, SO4. Well, we've got the 3 subscript indicating that there are 3 per molecule. Then we've got 2, so we've got 6 SO4. How many do we have on the product side? Well, we have no subscript here or anything. It's SO4, and we've got 4 of it. So that's a source of imbalance within those 2 entities. So it's good whenever you see a form or a reaction like this to be able to deduce what are the ions that are involved in making that molecule. Because when you can identify the ions, then you can very quickly say, I'm trying to balance SO4s on each side of the equation, rather than sifting through and saying, okay, I got to balance the sulfur, and then I got to balance the oxygen. It's easier to, you save yourself a little bit of time. It's much more efficient when you can identify the ions, in the polyatomic ions, as well as the monatomic ions. Okay, I'm going to clear all the drawings here. Does anyone have any questions? Okay. Now, the last one is NaBr plus AgNO3 yields NaNO3 plus AgBr. Now, if you're looking at these 4 different equations, I would argue that this is the one that's kind of going to be the most appealing to look at first. The reason being is all of these formulas, NaBr, AgNO3, NaNO3, and AgBr, none of them are particularly complicated. And what I mean by that is there aren't a bunch of subscripts, there aren't parentheses. Instead, you see a NaBr, that's a 1-to-1 ratio of Na to Br. Okay, so all of my sodium is right there. Okay, so I've got 1 sodium on my reactant side. Then I've got sodium nitrate. There's 1 sodium on the product side. So my sodium are balanced and accounted for. Okay, next up, Br. Well, I'm going to go ahead and label this. I've got 1 bromine on the reactant side. Lo and behold, I've got 1 bromine on the product side. So far, I'm 2 for 2 on different species being balanced. Okay, then I've got Ag and NO3. Ag, I've got 1 on the reactant side, and Ag, I've got 1 on the product side. Next up is NO3. I've got 1 on the reactant side and 1 on the product side. And again, one of the keys that helped me out with this was being able to identify the polyatomic ions, because then I didn't have to go through balancing nitrogens, balancing oxygens. Instead, I could just say, okay, this right here is an ionic compound made up of a silver cation and a nitrate anion. So I came up with everything's balanced, and so I can just go ahead and say, well, that's my right answer. That's a balanced chemical reaction. Does that make sense? Does anyone have any questions about any of this? Okay, thank you very much, Sakura. I'm going to go ahead and clear my drawings. And now I'm going to go on to what would be question number Let's see. Well, question number 14 gives you C4H10 plus O2 yields CO2 plus H2O. Now, the answer options that you're provided with are, you've got a bunch of different coefficients. And basically it's asking, what's the number that goes in front of all of these different substances to get this to be a balanced chemical reaction? What we can do is we can look at this and say, we can easily identify everything that's on the reactant side. We've got carbon, hydrogen, and oxygen. Now, I want you to be able to recognize that this does not have any ionic species involved. It doesn't have like a silver chloride or a silver nitrate or anything like that. And that's why we've broken it down to carbon, hydrogen, and oxygen. Does that make sense? Awesome. Thank you, Francisco. And thank you, Sakura. Wonderful. Chat. How do we identify that? That's a great question. So I secretly got a question of how do we identify that? Well, what you need to be able to do whenever you're looking at a chemical reaction that you need to balance is look at what are the different elements that are involved, the elements that are at play. So we've talked about molecules falling into, or compounds being ionic, or, and I'm going to say molecular / covalent. And in order to kind of distinguish these from one another, you need to have a periodic table at your disposal. So an ionic compound has a metal plus a nonmetal. And what you should basically do is you should say, does it have a metal? Because if it has a metal, it's probably going to have a nonmetal. That would constitute an ionic compound. Meanwhile, if you see a bunch of, and I'm going to use the very scientific terminology here, bunch O nonmetals. If it has a bunch of nonmetals, then you're going to say those are molecular compounds that are reacting with one another to form molecular compounds. Now, does that help at all? Perfect. The person who asked said yes, so I'm going to go ahead and go with that. All right, now I'm going to erase all of this, but use that as kind of a guiding light. Is it a molecular compound, or are there molecular compounds or are there ionic compounds? In the event that you see a bunch of molecular compounds, then you should say, I'm going to break this down to all of the different elements. And what I want to do is I want to have an equal number of carbons on the reactant side as on the product side. I also want to have an equal number of hydrogens on the reactants and product side, and I want to have an equal number of oxygens on the reactants and the product side. Now, whenever you do that, and whenever you're presented with a reaction and told you need to balance this or asked to balance it, well, what's kind of implied there is it isn't balanced right off the bat. But, you know, it never hurts to go ahead and look at something and ask yourself, is this balanced, yes or no? We can see that we have a total of 4 carbons on our reactant side and only 1 carbon on our product side. We have 10 hydrogens on the reactant side and 2 on the product side, 2 oxygens on the reactant side and 3 on the product side. So if you look at this right here, CO2 and H2O, both of those have oxygen in them, but all of that oxygen is going to come from O2. And so what that means is, well, in a molecule of O2, you have 2 oxygens. Does everyone agree with that? So in order to get well, 2 oxygens for this and 1 oxygen for this, obviously you have to have more than one O2 molecule. Does everyone agree with that? Okay, so just for the sake of beginning the discussion, if I said that we had 2 O2, would that give me enough oxygen to make a CO2 molecule and an H2O molecule? 2 of those O2 would be utilized for the CO2. And then you've got another O2 that, well, one of those oxygens can go to H2O, but then you'd have an extra oxygen. But do we see extra oxygen out here? No, we don't. So that should tell you there's going to be, well, complete consumption of all of the reactants to make nothing but the products that are listed. So the way that I like to solve and the way that I like to balance chemical reactions is not to say, okay, well, let's throw a 2 in front of here. And then, okay, well, that gives me 4 oxygen. So then I'll put a 2 out in front of here because now I have 4 oxygen on my reactant side. Because whenever you do that, it's almost like you're fixing one thing and then you realize you have to fix something else because of the way that you fix the first thing. So that's why this is balancing chemical reactions, from my experience, is something that kind of drives me a little bit crazy. But the way that I like to solve these problems is what I think is pretty simple. It takes practice, but I think that it's an efficient way to solve it. So what I always want to do is I want to put a coefficient, but use a letter to identify the coefficient in front of each of my different substances. So I'm going to put the letter A in front of C4H10. Okay, then I'm going to put the letter B in front of O2. I'm going to put the letter C in front of CO2, and I'm going to put the letter D in front of H2O. Now, what I'm going to do is I'm going to solve for the value of A, value of B, value of C, and the value of D. So the way that I'm going to do that is use that value, that A, and use that to set up simple equations. Okay, so I want to solve for the number of carbons on my reactant side and on my product side. So would everyone agree that I have 4 carbons in molecule A? Okay, so what I'm going to do is I'm going to say 4A. That's where that's coming from. I haven't defined anything. I've just said that in molecule A, I have 4 carbons. Now in molecule B, how many carbons do I have? 0. So what I'm going to do is I'm going to say 4A is equal to, because I don't have to add it to anything. Instead, I'm going to say 4A is equal to, well, the only molecule on my product side that has carbons. What would that be? C. So I'm going to say, well, molecule C has 1 carbon. So all that I'm going to do is say C. I could say 1C, but I mean, that 1 is basically, you can kind of ignore that. So does everyone understand, or does anyone have any questions on how I got 4A equals C? Okay, so that's my first equation. My next equation is for my hydrogens. Now, using the same model, does everyone, 10, Francisco, perfect. Didn't even ask for it, and Francisco was ready with the 10. Nice. 10A, do I have anything in molecule B where I should add anything? Nope. So the next place that I see hydrogen is not until molecule D, where I have how many hydrogen? 2. 2D. Okay. Now, I've got my first 2 atoms or 2 elements that are basically taken care of. Now I need to come up with the same sort of equation for oxygen. And I'm going to say 2B is equal to, and this one gets a little bit more complicated because I have 2 oxygen in molecule C, and I've got 1 in molecule D. But I'm just going to say 2B is equal to 2C plus D. Does that make sense? Wonderful.
You lost me.
I lost you. Where did I lose you? Were you with me for carbon and hydrogen?
Yes. Where did the 2C come from?
The 2C came from, I'm making an equation for oxygen.
Oh, yeah, I forgot. I thought it was on hydrogen. Okay, never mind. I got it.
Okay, perfect. Thank you very much for that was good feedback. I like that. Okay, so we've got these 3 equations. Now, this is the part where it's kind of a metaphor for life. We've got to take a leap of faith here. And that leap of faith is we're going to say A is equal to 1. Now, I saw 2 people's eyebrows go from this point to about here, where they just thought, what? Bear with me. Okay, now let's think about this. What we are doing is we're giving a value to that number or that letter right there. Now, if I put A equals 0, how many C4H10s would I have? 0. So I wouldn't want to define it as 0. And if I give it a value of 1, well, that's saying that there's at least 1. So I wouldn't want to say half or 3/4 or anything like that. This A might end up being like 6, depending on how everything else falls out or how everything else falls together. But when we define A as 1, then we're starting somewhere. It might be more than that. There might be a multiple in there, but we'll deal with that when we can, or when we need to, really. Okay. And we're using this simply as our means to solve for the value for B, C, and D. Is everyone with me on that one? Okay. So we're going to say A equals 1. Now, the great thing about this is when I plug in A equals 1, and I'm going to plug it into this equation right here. That was a really poorly drawn star there. What is my value for C? 4. Exactly. So now I have values for A and C. Okay. So right now, if I were to show a smiley face for progress of this problem, I would say we're right here. You know, it might turn into full smile, but for the time being, all that we've got is this. Okay. Now, when we have the values for A and C, well, can we do anything with this equation right here? Yes, we can. And when we do that, we learn that the value for D is 5. Okay, so let's update the smiley face. We'll go there, but still kind of like I don't know. Okay, so now we have the value for A, C, and D. Our last equation, 2B is equal to 2C plus D. Okay, we don't know the value for B, but we know the value for C. We know the value for D. We just generated those. So we can say 2B is equal to 2 times 4 plus 5. Does everyone agree with that? Okay. So now what we're looking at is 2B is equal to 8 plus, that would be 13. Okay. Divide by 2. So 13 divided by 2. Okay. So I could substitute all of these values that I've just come up with. 1, 13 halves, 4, and 5. But what's one of the things that I talked about on the previous, or that I talked about in the previous solving? We don't like fractions. We like whole numbers. So how do we take care of this 13 divided by 2 and make it a whole number? seeing a chat and I saw some. Yes, exactly. We multiply it by 2. That's perfect. So we multiply this by 2. Okay, so if we multiply one of those by 2, what do you have to do with all of them? Multiply them by 2. So then we get our coefficients. This is, I'm going to switch color. I'm going to go with a burgundy. 2, 13, 8, 10. Because I multiplied all of my coefficients by 2. Now let's think back. Let's kind of do a processing of this. We set our A equal to 1. Did that cause a problem? Did it end up being 1? It didn't cause a problem, and it did not end up being 1. But you know what? We had that multiple, we had that fraction, and we took care of it. If this was 13 divided by 6 or something like that, what would we do? Well, we'd multiply that one and all others by 6. So now let me just tell you something. Maybe I have it set up this way. I don't know. But somebody asked the question in the chat. Oh, I can, what? That's crazy. That is okay. Sorry about that. Somebody asked in the chat, so do we just assume that A is always 1? Yes. That's where you start out, because you know that it has to have some value. It can't be 0. You certainly wouldn't want it to be a negative number. Oh. And then, sorry, somebody pointed out the very important part of this whole exercise. Okay, so if you set A equals to 1, all of those other equations, well, they kind of fall into place. We're confronted with a fraction. Well, we just multiply whatever that fraction is by the denominator, and then we multiply all of the others by that same denominator. This is, I would say, very, very efficient and effective for solving most reactions. And I say most because when we talk about ionic compounds, most ionic compounds don't require this significant of a calculation, because generally it's going to be 1 cation plus 3 anions. And so your ratios are a little bit more clear than what your molecular reactions consist of. It won't, oh, okay. Okay, I have a great question that says, can we make any other letter besides A be 1? And that is a great question. I would argue that yes, you can, but with the qualifier of, let's look back at what we solve for. Okay, so if you had said B equals 1, would you be able to do anything with this value? Nor this, and you'd end up here. And so then you have 2 variables that you're trying to figure out the value for. And so the algebra is much more complicated for that. So the way that I treat these sorts of equations is, my default is I'm going to set A equal to 1. I'm going to solve the reaction. And then the last thing that I'm going to do is I'm going to confirm that I have the same number of each element on the reactants and the product side. In the event that something goes haywire in my solving process, well, then I'll look back and I'll say, okay, I set A equals to 1. Whenever I set A equals 1, how many other values do I learn from that? So by knowing that A equals 1, or by establishing that A equals 1, that actually kind of gave me A, C, and D. So it's almost like the best value comes from giving that, or giving A the value of 1. Okay, now there's another question. So the simplest equation should equal 1. Simplest equation, I think it's. Okay, let me see about that. Oh yeah, those are my settings that make everyone send their message only to me. So the question that I got was, so the simplest equation should equal 1. I think that that's probably, if I understand your question properly, I believe that would be the case. And then I have a request to do one more example. It's 11:29. I'm kind of getting tired. I think I might take a little napper. No, I will do one more reaction. Give me just a minute to get a good one. Let's go with. Oh, and then there's another thing in the chat. Class is about to start. Our class? That's true. Okay. Let's see. Okay. Okay. Actually, let's see what. Yeah. Okay. So I am going to do one more reaction. And the reaction that I'm going to do is see. Oh, wait, no. I know what I'm going to do. Oh, yeah. 6, not G. Okay, there we go. Yeah. Okay. So we will do C6 H12 O6 plus O2 yields CO2 plus H2O. Now, this is very similar to the last question that we saw, or the last reaction that we saw. Both of these are combustion reactions in that they take a hydrocarbon and they react it with O2 to produce CO2 and H2O. So here what I've got is I've got a little bit of a wrinkle in this one compared to the last one. I've got A, B, C, D. What I always like to do whenever I'm doing these is I like to write my coefficient and then underline it, because I don't want to, like, this C coefficient in front of CO2. I don't want to read that as CCO2 and do my math wrong. Okay, so I'm going to say A, B, C, and D. I like to set up my reactions or my equations: carbon, hydrogen, and oxygen. And then I will say carbon has 6A equals C. Hydrogen is 12A equals 2D. And oxygen, I've got 6A plus 2B equals 2C plus D. Okay. So A equals 1. Whenever I know that, C equals 6. Check. Okay. 12A equals 2D. 12 times 1 equals 2D. Divide by 2. Divide by 2. D equals 6. Now, 6A plus 2B equals 2C plus D. Well, I want to isolate 2B and put the B by itself. 2B equals 2C plus D. That would be minus 6A. So 2B equals 12 plus 6 minus 6. And 2b, and you see my poor handwriting show up, that looked like a 26 for a second, and then I had a micro or maybe a nano panic attack because I was like, uh-oh, 26, that's not right. So 2b is equal to, well, these guys basically cancel one another out. 2b equals 12, divide by 2, divide by 2. B equals 6. Okay, so now let's go ahead and punch these in. You know, I need to draw my lines though. Okay, so red, there needs to be a line there, there. I need to get the purple back. Okay, so a 1 coefficient in front of the C6H12O6, which that is the formula for glucose. 6O2, 6 CO2, 6 H2O. Okay, I want to go ahead and add up everything. On my reactant side, I have 6 oxygen plus, that would be 12 oxygen. So I have 18 oxygen on my reactant side. Then I'm going to do a little colon there to divide reactants from my products. I have 12 and 6 more, so I have 18. Why am I adding? I'm doing it wrong. That's oxygen. Oh man, this is embarrassing. Okay, so I balance my oxygen, 18, 18. Okay, carbons. Let's try this again, Joel. There's 6 carbons. Lo and behold, 6 more. Hydrogens, there's 12, and there's 12. All right. How does everyone feel about this? How does everyone feel about my handwriting? My 6s look a lot like lowercase b's. Thank you, Francisco. Thank you. So these two reactions were fairly similar to one another. And I did that intentionally because, well, I wanted to make the last one, or sorry, this one a little bit more challenging than the previous one, but still keep that same, like, it works sort of mentality in place. I'll probably balance some more. That makes it sound like a magic trick. I will balance all of the equations probably in Monday's session. And again, I'm going to record that and post that on Canvas. But that's what I got so far. And that's what I wanted to talk to y'all about. I'm going to be posting an announcement on Canvas today about the quiz that is going up at 12:20 today. That closes on Saturday. That's quiz number 5. Quiz number 4, I've removed from the grade book. That, don't worry about the numbering. That quiz will come back and you'll have the opportunity to do that much later in the semester. It'll be like a, maybe like a final exam review quiz or something like that, so that we can maximize the numbers. Question of only chapter 4 or 5 on the test. Absolutely correct. Chapters 4 and 5. And so my plan is in Tuesday's meeting, our actual like scheduled class, I'll try to clear up anything that anyone has about chapter 4 homework. Your quiz that is up at 12:20 today is fairly simple in the sense that it's asking about like symbols. So like AQ next to an ionic compound. Spoiler alert, that means aqueous. That means it dissolves and dissociates in solution. So it's kind of minimal, but I will post an announcement about that later in just a little bit. Next question. We had some questions about the exam. The exam number 2 or a previous exam? And I don't know who this we is. Exam number 1. Okay, I'm happy that, so there are 2 questions that I will be posting an announcement. Maybe these are your questions, I don't know, but I'll be happy to answer any questions after I say this. There are 2 questions that I'm going to post details about that they are keyed incorrectly. And so that means that there are a handful of people who got them marked wrong, and I want to give those points. The problem is, it's not even a problem. Not everyone has the exact same question numbers. So for one person, the question that I'm going to post might be question number 4, and for another person, it might be 27. And so if I said, hey, everybody, check if you got question number 4 right, that wouldn't work. So anyway, yes, I know it's 2 questions, but it's 2 questions that end up different numbers for different people. So like I said, I'm going to be posting an announcement about that. Didn't you mention extra credit? I will be covering extra credit, and I'll go over that in an announcement. Yeah, that sounds good. An announcement or the next lecture. So expect an announcement later today about the quiz. Expect an announcement later today asking in the event that you have, or asking you to look back at your exam and confirm that you got questions right or wrong. And I'm going to give like a screenshot of the question, so you'll be able to look at that as a reference. And if you got it wrong, then I think what I'm going to do is make like an assignment, an ungraded assignment on Canvas, so then you can submit like, hey, I got those wrong, rather than every single person emailing me that. Okay, I have a question that is, are there Monday classes now? Like I said in my announcement, I'm going to be on here Mondays 11 till about 11:30, just going through some homework problems. Same thing on Wednesdays. These are not classes. These are, if you have the time to come and you want to come, by all means. But I kind of want to, rather than just say like, hey guys, we missed a week of class, watch them extra videos. I wanted to give you guys a little bit, another forum or another venue to ask questions and just get more content from me. So to answer your specific question, there are not classes on Monday. Anything else? Okay. Well, I hope you guys have a wonderful afternoon. On 3, break. 1, 2, 3, break. Perfect. See y'all.